welcome everyone to another session of INF 164. So in this session we are going to cover object-oriented programming, specifically the 4 pillars of OOP. So my assumption is that you went through those, I think it's 5 videos. So the first 2 videos, I think it was introduction to OOP and also an array of objects, list of objects. Then the second part, I think it was single form applications and multi-form applications. Then the last video was the console application one. So in this video we are going to continue with the 4 pillars of OOP. So as I stated, the prerequisite is those 5 videos, because if you didn't watch the console application ones, you'll be a little bit confused in terms of these console applications. So let's get started. So I'm gonna start with a quick sort of introduction of these 4 pillars of OOP. So they are basically 4. So you have encapsulation, you have polymorphism, you have inheritance, then you have abstraction. So when we talk about encapsulation, so encapsulation refers to the bundling of data. So when you bundle data and methods, that's encapsulation. You are encapsulating the data, but we'll get into detail now. It's just a basic introduction. The keyword is bundling. Then with polymorphism, so if we destructure this, when we look the word poly, it means many. Then morphism, it means forms. So this means many forms. That's polymorphism. So in object-oriented programming, when we look at polymorphism, it's the ability of a base class to appear in different forms. So we'll get into that. This is just basic theory. Then we have something that we are all familiar with, inheritance. So you know that naturally when you have a kid, they will inherit certain properties from the parent. So you have a child, then you have a parent. So this child will inherit things. For example, if you look at these two, you can tell that this child belongs to this parent because they have certain features, or this child inherited some of the features from the parent. As you can see, the ears, you can see this one, there's no doubt that this child belongs to this father, this specific father. Even the hairstyle, you can see that the hair, it's similar. The head, it's inheritance. Even the eyes maybe, but some features you can see that this kid inherited, but the ears, you can tell that this is definitely or this child belongs to this parent. So as easy as that, that's inheritance. The one you know from biology, it works with programming. Then we have abstraction. So abstraction is when we hide unnecessary details. For example, if you want to model a person with coding, so it's not possible to represent the entire thing. So some things are necessary. If you want to model a person with coding, some things are necessary and you want to hide or remove them. For example, you can be interested in the name. So in real life, what's important is the name, it's the age, it can be the surname, the gender, things like that. So you cannot include everything. You cannot, legs are not important, hands are not important if you are modeling a person. So that's abstraction. When you hide unnecessary information, you are abstracting. So You are hiding certain things which are not necessary. So those are the 4 pillars of object-oriented programming. So for today, we are going to cover encapsulation and not polymorphism and inheritance. Then for the remainder of the week, we'll do abstraction and polymorphism. Actually, you've done abstraction indirectly. Encapsulation, you have done it. What you've been doing was encapsulation. So when you were creating classes, you were encapsulating. So let's consider the actual definition from your slides. So here they are just stating that OOP is a programming paradigm that uses objects and classes to design and structure code. So as I think from 154, you started with sequential code. So the structure of your code was sequential. So we had sequential code, sequential code. So that one runs line by line. So your code is structured in a line by line fashion. So some problems cannot be solved with this sequential approach. So you moved to selection, decision making. So you moved to structuring your code in a decision based on some decisions. So that's what you were doing. Then we learned that this cannot solve all coding problems, so we extended our knowledge to repetition, so to your loops. So it's similar to decision, but the difference is that you can go back, you can have some looping, or you can continue, but you had repetition. Then after repetition, you moved to structuring the code. You moved to arrays, something like arrays. Then you structure your code using methods. Maybe this method, you have different like methods that you can structure different parts of your code. So this is what we did in INF 154, but this is not enough. So to structure or to model things using these approaches, these approaches is not enough. Hence we introduce this OOP paradigm. So but we covered how to create classes and objects, so, and even arrays and stuff. Like, we did many things. Now we are just extending the knowledge. Then you have the 4 pillars of OOP, which are guiding principles that help developers create more organized, modular and maintainable software. So with this specific paradigm, it's not easy to maintain the software because there's a lot going on. Hence we need to structure our code for easy maintenance. So as I said, the 4 pillars, it's encapsulation, abstraction, inheritance and polymorphism. So encapsulation involves bundling data, which are your attributes, and methods, which are your functions, that operate on the data into a class, into a unit class. So the keyword, you have data, you are bundling data plus the methods into a unit, into a class. So it's the bundling of data and methods that operate. So these methods, they operate on that data into a unit that we call a class. So that's encapsulation. That's what we've been doing. So it hides the internal details of an object's implementation and exposes only the necessary interfaces to interact with the object. So with these classes, you will see that when you use classes, you don't care how they were created. Specifically predefined classes, for example, when you were using the random class, you were just saying random r equals to new random something like random, then you can generate random numbers r dot next 1 up to 6, something like that. So you don't care how this class was implemented. So the implementation details were hidden from the user. So, and exposes the necessary interfaces. You see, the necessary interfaces is the constructor, this next method. So this is the sum of the necessary interfaces. We don't care how the class was created. We only care about how we are going to use. Same applies to the classes you are going to create. So whoever is going to use your class, if you are going to publish that class, won't care about how the class was implemented. They only care how the class functions. In that case, we refer to the constructors and specific methods that you are able to expose to the user. So encapsulation helps to ensure data integrity, reduces the risk of unintended interface, and promotes information hiding. So most of the information is hidden here. The user cannot alter things from the class because they don't know much about the class, so they cannot change things that are not supposed to be changed. They can only use, they are limited to using specific things. They don't have full access to that class. Hence it ensures data integrity, which reduces the risk of unintended interface and promotes information hiding. So that's encapsulation. So as an example, we can use this one. Actually, let's use this one where we have a student and stuff like that. Let me create that first. So I'm going to create a new project. In this time I'm going to create a console application. So we learned how console applications work, so I'm not going to explain that. Then I'm going to browse. I just want INF 164, not 272. 164. Then I'm going to say OOP. Let's say OOP2. Actually, I wanted to select this folder. Then I'm going to say OOP2. Then I'm going to click next. Then the rest I'm just going to click next. Doesn't matter what you do. Then this is going to create a basic console application. I'm not a big fan of the structure, hence I'm going to go to this website, or let me copy the website. I don't like this template, so that's why I'm doing this. I'm going to go to Chrome, then paste that. So I want the full one, this one. So I want this structure instead of this shortcut. So I'm going to remove and paste. But in my case, the namespace is the name of my application. So if I go here, you will see that the name of the application is OOP2. So I'm going to use that. So this is my namespace. So let's run this. We are expecting hello world the way it is. So I'm not going to explain much about console applications. You guys know how they work. So this is our main function where the classes are going to be executed, or where every code the code, when you click run, the code that is going to be executed is the code that is inside the main function. So let's proceed. So we wanted to create that specific class, yeah, that student class. So let's proceed. They have a name and an age, so we are going to do that. So I'm going to add a class. So here on the project, I'm going to add class. Where do here? Let me close that. So I'm going to right click here. I'm going to add a class. Then this class, I'm going to call it student. So let me put the mic so that I can type. So I'm going to call it student, like that. Then I'm going to make it public. So we know by now the meaning of access modifiers. So we are making it public so that it's accessible on other classes. Then we have two properties, private ones. So I'm going to say the name, which is a string. So string name, private string, and also integer for the age, then age. Then we know that when we have private attributes, we have to create get and set or properties. So I'm just going to use shortcuts. I'm going to say name, then the data type is string, then name, then I'm going to use a shortcut. You can use that long approach, but also you can use the shortcut approach. Then I can create the other one for age. So I'm using the shortcut approach. I have my private attributes. Then we have properties. We learned that properties, there are special mechanisms that uses the get and set method to either write data to the private variable or to read data from the private variable. The get, we call that a getter. It's going to get this private variable. The set is going to set this to a certain value. So I did explain all those things, so let's not waste time on that. So we are going to have that, or alternatively you can do it like this, where you have, then you can do it the long way. The get will get the name, then the set will set the name. Same with the age. The get will get the name. The set, normally you can validate if the value is greater or equals to 0, it's going to be validated. So but for us it's not necessary for now to validate. So we have this class. How is it represented in memory? In memory, we know that we represent a class with its properties, our public attributes. So we have this student class. So this is the class. It has properties, name and age. So this is our class. This is a blueprint that is used to create objects. So I did explain that. So this is encapsulation. By doing this, you are encapsulating the data and the methods. For example, we can have certain methods, the constructor. So I did explain what's a constructor. Let's have a default one. Then we are going to have the overloaded one. If you want an overloaded one, so I'm just going to click tab for everything. except here it's repeating. So I assume that by now you know how to do that. So that's a constructor. So those are constructors. We have the default constructor, the overloaded constructor. Then we can add a method for printing. So this is going to be a void method. So it's going to print the name and the CNA. So console.log. Then I'm just going to use the $sign. The name is equals to the name. Then you have the CNA, or the age actually. Age is equals to the age. So nothing complicated here. So not console.log. This is not JavaScript, so it's right line. So as I said, the prerequisite of this is that you've watched all those 5 videos, because if you didn't watch any of them, you won't understand what's happening. But if you did watch, this will make sense. So we have this class that has 2 properties and 1 method. The constructors, we don't normally represent them, so we have the print details method. So I'm going to do that. Let me select. Is this the erase? I want to. Yeah, we have the print details method. I'm going to edit. So this was the encapsulation part. We encapsulated these are properties and the respective method, or this data fields and the respective methods that operate on this data. So that was encapsulation. Then the rest is history. This is an easy class. If you watched those videos, this should be an easy class. So let's use that class on our program. To create an object, I'm going to show you different ways you can create an object. So method 1. So this is method 1. So method 1, you can use the default constructor. So I'm going to say student, let's say s1 is equals to new student. So I hope you guys remember how this works. So with the default constructor in memory, it's going to create a student object called s1. Then it's going to create it using the new constructor. So the name is empty by default, and the age is empty, it's 0. The name is empty, the age is 0. Then it's going to create the copy of print details method. So this is the copy of that. So this is our object, just by using that new keyword. This line of code. Then when we want to populate the names and stuff, you can access them. You can say s1.name. When I say s1, I'm referring to this. When I say .name, I'm referring to this block. So whatever I assign here, it's going to be the corresponding name. So s1.name is equals to maybe something like this. s1.age is equals to this. So this is going to populate. So my s1.name, it's no longer empty, but it's this. s1.age, it's now 20 like this. So we have this. Then if I call s1.print details, that's how you call a method. We covered this. So it's going to execute this method for printing the details. So it's going to print the name. It's going to execute this method on this specific object. So it's going to execute the method on the specific object. So it's going to the name is going to be John, the age is going to be 20. So it's going to have that. So it's going to print that. So when we execute the code, everything should work as expected. So you have that. So let me zoom in. Yes, you have something like this. As easy as that. So nothing complicated so far. It's just a quick revision of what you guys did with classes. Here was encapsulation. Encapsulation is what you've been doing. So that was encapsulation. So the important thing that we noticed about classes from day one is that a class has fields, data, or you can call them attributes. Then it can have methods. We call those functions. So we know how they work. So then let me we are still doing different types of declaring the object. So method 2 is the overloaded constructor. So method 1, it was the default constructor. By now you should know this should be easy stuff actually. Then with overloaded constructor, I'm going to use this. So now we are trying to call the overloaded constructor. So the overloaded constructor, we know that it's a method. It receives the name and the age. So we can pass the name, maybe something like this, then the age, something like this. So how is this going to work? This is going to call this constructor, then it's going to pass the name as this and the age as this. The age as that, then it's going to initialize name to that and age to that. Basically it's going to create a new student using those parameters. So this is going to be like this. S2, it has a name, then it has an age, then based on what was declared, it's going to initialize the values to that. So we are going to have something like this in memory. And also the print details. You see, every object has its own copy of that method. So this method cannot exist without an object. So you have to take note of that. So that's it. Then we can also call the print details also on this one. So we can say s2.print details, then that's all. So when I execute this, I'm expecting two different things for the first object, for the second object. So this was the second method for creating objects. Now we are going to look at the third method for creating object. So I'm not sure about the specific name, but I'm just going to say the shortcut approach. So with the shortcut approach, it's similar to that, but you are going to have something like new student, then you are going to have something like this. So this is it's another method of creating objects. So you have to note that, because sometimes you will think that it's syntax errors, but it's not. So you have to initialize whatever property you have. So in this case, it's the name and the age. So we have to initialize name to whatever, let's say something like this. Then you are going to say age is equals to maybe anything. So this is going to create a new object, and it's going to initialize name to this, and it's going to initialize age to this. Notice that here we are not using a constructor. So let me see if I can get the actual name of this method. what do we call this? So I'm going to paste and see. So this is the object initializer syntax. They call it an object initializer. So let's put the appropriate name. So this is the object initializer. And I think one thing that you can't do, let's remove the constructor and see if it's possible to use the object initializer. I think you can't. So without a default constructor, you cannot use the object initializer approach. So just take note of that. Sometimes you will have errors. If you have an error while you are trying to use the object initializer approach, this means your thing, you didn't have the default constructor. So it's very important to have the default constructor when you are dealing with such things. So yeah, so you have those. Then the next thing, so that was the shortcut approach or the object initializer. This were the 3 ways of creating objects. In terms of visualization, it works the same. You are going to have S3 that has a name of that, then it has an age of that, then it's going to have its own copy of print details. Then this is your actual object. Remember, with the class, it's a blueprint or it's a prototype, or you can say it's sort of a sketch, but a sketch is not the correct term. It's more specific to the application, but in this case we are referring to these we are referring to the general case. So we can also call the print details. It's going to work the same. Also, we can update the details using that. We can get individual things. So that's what I wanted to emphasize. So these were the 3 ways of creating objects. Then the other thing that I can demonstrate is the var keyword, or I think it's dynamic types. So this is not similar to JavaScript. This is var keyword in C#. I'm not sure about C++, but I think in Java it's also there. But in this thing, the var keyword, it's used to, I think, dynamic types, if I'm not mistaken. Normally you don't have to know the theory, but what is the use of var keyword called in C#? Implicit typing. So it's implicit typing. So what's the meaning of this? Var keyword can store any data type. So if I say var I don't know, number is equals to 20, it doesn't matter whether my data type it's a string, it's an integer, it's a double. So the data type is going to be determined when I assign a value. Automatically, when I assign a value, this number will become of that specific type. In this case, it's going to be an integer. So if I say var maybe text is equals to hello there, this text is going to be a string. If I say var maybe is valid is equals to false, this is going to be a boolean. If I say var maybe array is equals to new int, then I can say 1 2 3 4 whatever, but yeah, you get the idea. So this is going to be of type array, which is an array of integers. If I say var student is equals, s4 for example equals to new student, then this is going to be of type student. So the use of var, it's a very important concept because it allows you, it simplifies the work for you in terms, but you'll see the real application when we get to polymorphism. But just keep in mind how to use implicit typing. So num is of type int, then text is of type string because of what you have on the right, then is valid is of type boolean, then we have array which is of type integer array, then this one is of type student. So just take note of this implicit typing. Then the next thing that you can have with classes is a distractor. So a distractor. So remember we had a constructor. So let's just compare them. So we have two possible things. Let's start with what we are familiar with. So a constructor is a method used to create objects, to create or construct objects. Hence we have the keyword constructor because of construct. So that's a constructor. What other properties do we know? In terms of other properties, we have, it has the same name as the class. Then yeah, then you can have an overloaded one, you can have default one, it doesn't matter. Then on the other hand we have a distractor. So it's a method used to destroy or distract, from the keyword distractor, objects. So this one, it has the same name as the class, but starts with a tilde. So if you don't know a tilde, is that symbol next to the escape thing on your keyboard. If you look at the top corner, you have the escape, then you have that tilde thing, which button. So it starts with that. So let's see how it works in action. So the constructor, we are familiar with it. Let's demonstrate a distractor. So I'm going to say public void distractor. No, it's not a void, it doesn't have a data type. So if I do this is a constructor. Distractor, we said it should start with this. Does it start with this? Yes. Why is it giving me errors there now? let me just do this. I'll fix that. Or maybe I'm thinking of C++. Maybe it ends with a tilde, because nah, it should start with a tilde. So let's see what could be the issue. So okay, student, it seems to be correct. What am I missing? Let me rewrite this and see which doesn't make sense. I'm just changing the position. Maybe I can't use public. Okay, it can be public, so that was my issue. So let's add to the table. So this one is always public, because you want to create objects, but this one, it doesn't have an access modifier, or return type. Even a return type, it doesn't have a return type, similar to this one. This one doesn't have an access modifier at all. So, and it's also called automatically. You will see when I execute the code, there's nowhere we called the destructor, but you will see that so it's not working. Let's see what's the issue. The construct is supposed to be executed. Let me copy. Specifically the destructor. Okay, you just have to create it. So let's not. So I think you just have to create it like this and nothing else. So this is going to be automatic. So it's something like this. So the destructor is used, just know the concept behind the destructor. It's used to destroy objects. They won't normally ask you to write one, but they would ask you maybe in multiple choice or whatever question they might ask. So that was the destructor. You just have to know the theory behind the destructor and the constructor. The constructor, you must know how to implement it. Then the next thing is static variables or static members. So we are still on OOP concepts. So this is all related to encapsulation. Not necessarily encapsulation, but it's in general OOP theory that we didn't cover, or that was not included on those videos because the content is always updated, so I'm also updating here. So a static member, so you can say it's a variable, or you can say or a method. So it can either be a variable. Remember, members of a class can be variables or methods. Declared using the keyword static. So what are the characteristics of static variables? The characteristics of static variables is that only one copy of the member in general is created for the entire class. So it's created for the entire class and is shared among other objects, or all objects actually. So you have one variable that is shared among objects. Then the other important thing is that it is initialized before the object is created. So you don't need a constructor to create a static variable. Then the other thing that you can do, or the other important properties that you don't need objects to use a static member. So those are the properties. If we look at this class, you cannot use this method without creating objects. You cannot use these properties without creating objects. If I say, for example, maybe, I don't know, string my name is equals to student dot name, this is not going to work because these are not static variables. So let's see how static variables or members work. So let's say, for example, int count. Let's say public int count is equals to 0, but we are going to put the keyword static. So we said public static, this is the keyword static, then the data type, then the count. So in general you have the access modifier, then you have the keyword static, then you have the type, then you have the name. Then mostly you have to initialize it to something. So we want to keep track of the number of objects that were created. So on this constructor, whenever an object is created, I'm going to increment count. Same with this other constructor. So whenever I want to keep track of how many objects were created, hence I'm doing this. So let's see how it works. So before we even run the code, what's going to happen is that you are going to have this class. This class has it's a student class. Before everything happens, it has name property, then it has the age property. So we know that these are descriptions, they are not actual values. But when it reaches the static variable, which is count, it's going to say count, but it's going to initialize it to 0. So this is going to be an actual variable. Then it has this print details, which is not solid yet. This one it's a concept, this one it's a concept, this one it's a concept or description, but this is an actual variable. You will see that before I create any object, if I say on the main, if I say maybe at the top, before even creating object, console.log, write line, then I'm going to say count is equals to, then I can add. How do we access static variable? You mention the name of the class, then you specify the static variable. So as you can see here, we said write line count, then student.count. Then according to this, it's going to print 0. So let's see if that's the case. So if we execute this, I have built-in errors. So let's see what's that error that we are encountering. So here it was that error that I was demonstrating. So then where's the other error? I wanna see. I removed the closing bracket. So yeah. So you will see that at the beginning it's going to print count is equals to 0. This is a static variable. You don't need an object for it to work. Hence we can directly access the variable. Notice that after creating an object, you will see that when I say console.write line, let me copy that code. So I want to demonstrate how it works. Also these ones. So for every object I'm going to call the count. So when I execute this code, we are going to have this count. You see it's increasing as we create an object. Why is that the case? This is because we have originally we have this. So we all agree that we have this. So we have this. Then initially my count is 0. Then when I create the first object, this one, so this one I'm creating it using the default constructor. So we are calling the default constructor. As you can see, the default constructor is going to increase the count by 1. So after creating S1, my count will be 1. So will be 1. So now will be 1. So this is no longer there. We have 1. Then when I create the second object is created using the overloaded constructor. Hence it's going to call this, it's going to initialize and it's going to increment count. Hence we have the count. That 1 is no longer there. You have 2 at that instant. Then the last one, the shortcut approach or the object initialize approach, we are creating an object. Remember, when we are using the object initializer, indirectly we are calling the default constructor. So the default constructor is going to be called it's going to increase count by 1, and also we are going to initialize the values. So this is going to go to 3. So it's going, that's why we have that pattern of 1 2 3 on our console. So that's why we have 0 1 2 3. So then the other thing, it's a static method. So if we wanted a static method, maybe a random method that will do something, maybe public static sum we can make it anyhow, maybe a random method. It doesn't have to be related to our object because it doesn't depend on the object. So this is a random method that will calculate the sum of two numbers. So it's not related to the object, is not related to the name, the age. It's just a random method that will calculate, given two numbers, it will calculate the sum. So how do we use that static method? We can also use it here. We can say maybe console.write then we can just print the sum of 10.5 and 10.6, not just sum. So where do we get the method? We get it from the student, then we can calculate the sum. So as easy as that. So there's nothing fancy to call a static method. You mention the name of the class, then you mention the method, then you pass whatever values. So this is going to call, notice that we didn't have to create an object to access that. So when I execute that, you will see that it's going to calculate the sum. You don't need an object to use static methods. So that was part 1. So I'm going to copy this part 1, then I'm going to create a method so that if you want to run it, you can run it separate. So public static part 1 void. So I'm just separating the code since we are going to include other code here. So I can call part 1 if I want to test part 1 only. This, whatever code we were running, this doesn't change anything. I'm just separating the code. So this is static variable. So I can put it just to comment if you want to use the code. But this was just the use of static. This was revision. This was OOP. So part 1 is OOP. Overview of OOP. That was encapsulation and other terminologies. So we saw multiple terminologies like the destructor, static methods, static variables, implicit types. So here it's implicit types. So we saw those things. So that was just basic theory. So I didn't want to make a long video, but apparently it is what it is. So let's proceed. So The second part is going to be inheritance. So inheritance is going to be a little bit quick. So let's do part 2. So part 2. So you can debug this separately by uncommenting, but now we are going to, and notice that this is not the same, it's not necessarily the same static we were doing with classes. This we are doing it because of console applications, but also you get the idea that we don't want to relate these methods to this class called program, hence we want them to be static, because if you don't use static, I think you are going to let me do this. Then let's call part 2 and see. I think I demonstrated that you are going to get issues, hence you are going to give the static keyword. So yeah, so this is part 2. Part 2 we are going to cover inheritance. So I did a basic description of inheritance. So that was part 1. So inheritance. Again, inheritance, we have to, it's going to be quick. So inheritance allows us to create a new class. It allows us to create a new class from an existing one, from an existing class. That's inheritance. The way I showed you with that person, this child was possible because of this. You cannot have this without this. So that's inheritance. So we have the base class, or you can say parent. So we have the parent, then we can even call it the super. So this is class. So you can call it base class, parent class, or super class. It's up to you. So you have this base class, then you have the child. So you have the derived, you can call it the derived, you can call it the child, you can call it the base, not the base but the sub class. So super goes with sub, parent goes with child, derived goes with base. So these are the keywords. So you have a parent class, then you have a child class. So this is the new class that we are trying to create from an existing class. So that's inheritance. It's going to make sense now. So normally we refer inheritance, when we see inheritance so is a relationship. So it's a relationship. So why do we say it's a relationship? Because if we look real example, you can say a dog is an animal. This is a fact. So this is a relationship. A dog is an animal, then a car. So a car is it's a vehicle. Then you can have other examples. An apple is a fruit. Then a student is a person. So this is a relationship. So this means these are parents. So this one is a parent. This means animal, it's the parent class of a dog. Vehicle, it's a parent class of a car. Fruit, it's a parent class of an apple. Person, it's a parent class of this. And notice that one parent, for example an animal, can have different children. So it can be a dog, it can be a cat, it can be a lizard, so it can be anything as long as it's an animal. So but in reality, I think, I'm not sure about the opposite, but I think, okay, every dog is an animal, every cat is an animal, every lizard is an animal, but not all animals are dogs. So my arrows are wrong here. So you see now, these arrows are wrong. So they are supposed to go up. With your databases, that's how you deal with them. So they must go up like this to demonstrate it's a relationship. So a dog is an animal, a cat is an animal, a lizard is an animal, but not all animals are dogs, not all animals are cats, and not all animals are lizards. Hence we don't have like this type of errors. So that was our inheritance, the definition. So let's consider a simple example. I'm going to create two classes. So let's create two classes here. I'm going to add a class. So let me remove this. So I'm going to add a class here. Then I'm going to call it animal. So we are going to implement animal. So we know that here it must be public, we don't want internal. So this is animal. So on this animal we can have I don't know, maybe a name. Now I'm just going to do shortcut get set. Then public, we can have a default constructor. Then we can have there's no need for overload, but we can have that. Let's say public void display name. So this will print the name of our animal. So we are going to do the console.writeLine. We are going to do that console hello, then we can print the name. So what did I do? Yeah, something like that. So that's an option. So this is the method is responsible for printing the name. That's all. So we want to keep things easy. So for now, so we are going to have an animal here. This is a class. So the animal has a name, and it has a method called display name. So this is our animal class. Then how do we actually do inheritance? Let me create another class, add class. Then I'm going to call that class doc. then again I'm going to public. So how do we actually inherit? So the syntax for inheritance. So syntax, we are going to have a public class, then you have the child, then you have the parent, then it's the normal class. So this means the child is inheriting the parent. This is inheritance. So let's put that to practice. So dog, then we are going to say animal. This means a dog is an animal, so that's inheritance. So here we are just going to add a method public dog for the constructor, then I'm going to say public void get name. Maybe console.writeLine. Okay, let's say I'm a dog. That one was I'm an animal. Then I'm going to say, and my name is, then I'm going to add the name. I'm going to explain how it works. Then with that one, and my name is like that. So we have this simple thing. So we are going to have a dog. So from the class, as you can see, the dog is going to have the get name. So this is our dog class. So we are going to have that arrow. So this means dog is an animal. So this is inheritance. So a dog is going to inherit whatever animal has. So the keyword the key things you have to know. NB, dog is going to inherit all the fields and methods of the animal class. So this means dog is going to have name, and also dog is going to have the display name. So in reality, dog is going to be like this. It's going to have the name that it inherited from this. Then it's going to have the display name that it inherited from that. Then it's going to have the get name. So this is inheritance. So dog is going to inherit all these name, display name, and it's going to add additional properties or methods. Hence we have this extra method. So that's inheritance. So let's look into that. So I'm going to go to program, then part 2. Then I'm going to create an animal. Then I'm going to use that shortcut method because it has a name. Name is equals to, I don't know, animal. So I created an animal. Then I'm going to create a dog. I can also use the shortcut something like that. So notice that I created the animal using the animal approach, using the animal class. Then I created the dog using the dog class. Hence I have this. So in memory I'm going to have something like this. So I'm creating a new animal that has a name animal. So in memory I'm going to have animal which has a name and also display name method. So this is an actual name, so I just said the name is animal for some reason. Then something like this. Then also I have on the other hand a dog which has things like that. So I'm going to create a dog which has a name of that. Then it's going to have the display or display name. It has a display name and it also has a get name. So hence we are going to have this. On the dog we are going to have the name, display name, get name because of inheritance. But on this we only have two things because it doesn't inherit from anywhere, hence it has those original things. Though we didn't explicitly say on the dog, if we check the dog class, we don't have a property called name, we don't have a method called display name. Because of inheritance, we are able to inherit these two things from the animal class. Hence, if you look here, this is valid. So then if we call the respective methods, if I say animal dot display name, I can do that. Then I'm going to say animal dot display dog dot display name, then dog dot get name. So this is going to be valid because of inheritance. I hope it's not that confusing so far. Then you will see that for animal display name obviously is going to say hello, I'm an animal, my name is depending on whatever name. Then for this one, for the dog display name, it's going to say I'm a dog and my name is, it's whatever. Get name, I'm a dog and my name is, oh hello, oh here is just a typo. I'm an animal. A dog is an animal because of inheritance. That's why we have this. So let's try to recap because this is very important. You have to get this. So let's relax. So we have two separate classes. We have an animal which have these private attributes. It has a private attribute called name, so it has the corresponding property. Then it has a method called display name. The constructor, we don't care that much about it, so we call this the parent class or the base class because it doesn't inherit from anywhere. Then we have the dog class which inherits the animal. So it's going to have the same things as the animal. it's going to have the name and display name, even though we didn't like rewrite them. And also it's going to add additional properties like its own constructor, obviously, and this specific method. So as I mentioned, virtually we represent it like this. You have this animal which has name and display name, and you have this dog class which inherits whatever properties and names from the animal class and methods from the animal class, and it also adds its own method. So then ideally it's represented like this, where you have, to avoid confusion, you can represent it like this, but to avoid confusion you can represent it like this. It has name, display name, and get name. So it has those things. Then when we create it, we can create this. Alternatively, instead of using, I think even this approach, maybe it might be tricky for some of you guys, but let's do it normal. So normally you would say new animal, then we can say animal.name is equals to animal. So let's use this syntax. I think maybe this one might be confusing for the first time, but if it's not confusing, you can use that. Name is equals to so you have this. So this is no longer confusing, I guess. So we are creating a new animal object. We know that by default, if we create a new animal object, it's going to have an empty name. Hence we are setting the name to this, so its name is going to be animal. Hence we are going to have something like this. Then same with the dog. Initially when we create a new dog object, it's going to have the name because it inherited it from the animal. Then it's going to display name, get name. This one is going to be empty until we say dog.name is equals to. The reason we are able to say dog.name is because of inheritance. Then we call the display name on the animal because the animal has a display name property. Then on the dog we have display name, which was inherited, and we have an additional one, which is the get name. Hence this is going to be the same code. So this is inheritance. I hope it makes sense. Hopefully, let's hope so. Then let's look at method overriding. We'll look at a last example if you didn't get it. So let's look at method overriding. For inheritance. So with method overriding, so if the same method is present, let's say on the base class and the derived class. So what do we want to do? If that's the case, the method in the derived class overrides the method in the base class. So let's try to demonstrate. Let's say you have in the animal class you have eat method, then in the dog class we know that it is inheritance. You also have the eat method. So to be able to override this method successfully in the derived class, so this is the base class, then this is the derived class. So in the base class you have to say public, then you give it a name. So you are going to say public, then you are going to say virtual, then you can put the data type, maybe void, maybe it, for example. So this is the method definition. The keyword is it's public virtuals. So this is the most important thing on the base class. Then on the derived class you are going to have public, then you are going to say override, then you give it a name, void, it, whatever. So this is on the child class, the derived class. Hence the most important thing is the override keyword. So notice that in the base class you have this, in the derived class you have this. A thing to remember them is that override, it's derived, so base virtual, so it's not hard to remember. So let's demonstrate that. Let's say we are going to do it without that. So on the animal class I'm going to add a method public animal, let's say it's a public void it, then we are just going to print console.write I eat food, animal food. So in this class we have the method eat. Then on the dog class I'm going to also add public void eat, then I'm going to say console.write line, then I eat dog food. So notice that we just modified the classes. The classes are still the same. You have the animal class, you still have the animal class that has a name, and it also has a display name. Nothing changed, we just added the eat method. So this is what we did. Then on the dog class, remember it inherits the name, it's going to inherit the display name, then it's going to inherit the it. So notice that it's inheriting the it, so it's gonna be tricky. Then now we are going to add our own it. So let's see how is it going to work. So the rest is going to remain the same. So we are going to say on our program, we are going to say let's test the eat method. This is overriding. We are going to say animal.eat and also dog.eat, and let's see what's going to happen. I have issues, so it's this typo here. Then let's execute. You will see that it's going to say I eat food for animal, and I eat animal food for animal, I eat dog food. for animal. So this seems to be a proper way, but let me show you something. Let me show you something. This is not the proper way anyways, but let me just show you something. Let's say animal dot is equals to new dot. So let's say dog 2. Then I'm going to say dog 2 dot eat. So don't worry, we'll get to polymorphism. This is just an example of showing you why the overriding is not working. You will see that for dog 2 it's going to say I eat animal food, even though we created a dog object. So the correct way of overriding is to use this syntax I was showing you. So on the base class we are going to say public virtual. This means we want to override this method on the base class. Then on the base class we are going to say public override. Then you will see that when I run the code now, it's going to say I eat dog food on the one I added, but don't worry, we are going to get to polymorphism. So I was just showing you why that doesn't work. So don't worry about that part, just worry about inheritance. For now we are focusing on inheritance. So that was that part. So let me see if there's still time to do an example. I think there is. So let's do one last example, then we end here. So for the last one we are going to create. So this was part 2 of inheritance. So let me separate. Oh, it's separated. So that was part 2. Then we are going to do part 3, which is an example. So I'm going to create a method. Part 3. So this one I'm going to say inheritance. So this is sort of like a real life example. So let's consider a real life example, or something that is relatable other than animals. And even though they are real life, but they are not real that relatable. So let's say for you guys, you have a person class. That's how they do your systems anyways. I'm sure on INF, I don't know if it's 171 you are doing database. I'm not sure which one, but on some INF you are doing things. Those are tables, entity diagrams. Wherever you are doing entity diagrams, you are doing these relationships. So last name. So let's say a person has these properties, then age. So these are the properties of a person. So there are things that I want to explain with these examples. These are the properties of a person. Maybe they can have print details. So this is a person object. So from this person, let's say we have a student. So a student is a person, so they can inherit. So we are going to have a student. Then we can say student number, then degree. So the degree they are doing. So that's a student. So yeah, the degree that the student is doing. Then So in C# we call this UMLs, but in databases it's entity diagrams or something like that. Then we have the lecturer. So the lecturer is also a person, so they can inherit. So it's maybe they have employee ID. Obviously they don't have student number. Then department. Which department are they teaching? So yeah, this is basic inheritance. So we know that in addition to this, because the student is inheriting from the, and also they have this, sorry about that, they have print details. Say they have print details. Then because of inheritance, we know, this is what we know because of inheritance. We know that they are going to inherit first name, so these are inherited properties. Last name, then age. Then for print details, it's there, so this is overriding, it's no longer inheriting. So we have method overriding, so this is overriding. If they have the same name, it's overriding. Then same with this, it's going to inherit the first name. So these are inherited things. Last name, then age, then print details is also overriding. So at the end, this is going to be your lecture. So these are additional things plus inherited information. Same with the student. You have additional thing plus inherited information. So let's see how it works. So let's try to create that in code. So I'm going to add a class. I don't know why I always open that, but let's add a class. Then I'm going to say person. So public class person. Or let me demonstrate on different folders so that we are not confused, because you already have a student, so it will be nice to have a different folder. So let me delete the person. So I'm going to create a folder, add a folder, then I'm going to call it part 3. Then on the part 3 I'm going to add a class, then I'm going to add the person class there. So sometimes you can have classes on different folders, so don't be confused. If you have that, it's not difficult. So this is a person, the base class. So the person, we said they have, so I'm going to skip the private attributes. You can do them, it's not necessary, but normally you must do them unless if they mentioned. So I'm going to use the shortcut approach. So I'm going to, the person is going to have the first name, which is get set. So this is my person, then string, last name, get set, then int for the age, get set, and they are public because these are properties. So this is a shortcut approach, but don't do that. Like, yes, this is valid, but for you guys, you must have the relevant private attributes, maybe private string first, name, something like that. But for me, I'm just doing shortcuts because there's no time. Then I can have default constructor, I can have an overloaded constructor. Yeah, something like that. So this, you know how to do constructors, so I'm just allowing the thing to complete for me. Then public, so we said the print details must be overwritten, so we don't want to inherit, we want to override. So this means we are going to use virtual, then depending on the return type, so this is print details, so this is going to print the details for the person. So for the person, we just want to print name is equals to, and then here I'm going to say first name plus semi plus space, then plus then plus semi. So here I'm just formatting last name. So yeah, something like this for actually even the last name. So I'm going to have this, so I'm just printing the details. Let me be specific, console dot write line person, then on the next line I'm going to print the name, which is the full name, which consists of the first name, last name, then console dot write line, then you are going to have the age, then that's the age. So this is easy stuff, you know how to do that by now. Here we are just printing the details, name, age and stuff. So this is the person class, we successfully created that. Ideally you would have those private attributes, but they are not necessary, but for you guys you must create them, otherwise you will lose marks. Then I'm going to add another class, which is student. So we said the student must inherit from the person, so they are inheriting from the person class, hence we have that. Then they are going to add additional attributes like student number or student number. So again I'm going to use a shortcut public string student number get set, then public string course, the course that they are doing get set. Then I'm going to have a constructor, default constructor, then student, then I'm going to have an overloaded constructor. So let me leave the overloaded constructor for now. Let's focus on the override. So we said the student will override the print details. So let's do that. So we said public override when we want to override the function. Then we can do that. Then here we are going to call our own print details. So we are going to say print details, not this, but it's the same vibes with the student. So I'm going to copy some of the code, from the person, because we are just printing. So it's similar to this, but we are adding some additional things. So let me check the person age. person age, so I didn't make it public. So on top of that, for the student, this we are going to specify that this is a student. The reason we can access the name, last name and age is because of inheritance, remember. So that's an easy step. Console.writeLine, then we can print the student number, then also we can print the course. So yeah, here we are just printing those, that's all. So we didn't do anything fancy, we just added the additional information. You see the advantage of inheritance. Instead of recreating all the things from the person, we are not recreating them, we are just reusing the same code. So we are reusing the same code and we are adding additional information. So that's the advantages of this. Then we are going to add another class for the lecturer, so we are going to add that. So I'm going to say lecturer add, then I'm going to say public, then they inherit from the person. So we said the lecturer must have employee ID and department, so I'm going to use the shortcut again, string employee ID get set, then public, department, and it's also a string. Then I'm going to use the get set. So we are done. Then next is the constructor for the lecturer, the default constructor. Then I'm going to have the method public, because this is overriding, so I'm going to override void print details. Then we can print the details of a lecturer. Yeah, same vibes. I can even copy from the student, it doesn't matter, actually it's the same code. So I'm going to paste on the lecturer. So this one, instead of student, is going to be lecturer. The lecturer's first name, last name, age, because of inheritance. Then the next thing, it's just the employee ID and the department. So that's all. So department, then employee ID. So this was our classes, these are our classes. So as easy as that. So let's try to demonstrate how it works. We know that this is what we did so far. Now let's actually create things. So let me go to the main program, and also since these classes are on different folders, to access them, I think, or let's try to just use them without specifying this. So part 3 example, let's create a person. Okay, they are accessible. So we are going to create a shortcut approach. Remember, the person has a first name, we can initialize whatever last name, is equals to, then we can specify the age. So here we used the object initializer or the shortcut approach to create this object. So if we say person dot print details, we know what we are going to get. So here, let me do this. So when we execute this, we must get the details of person. So you can see that we are getting person, then we are getting the name, the full name, and also we are getting the actual age. So we have that. Then the next thing, that was the person. So it's straightforward. We are using this object approach to initialize. So in memory we will have did we give the person a name? We called, let's call them P1 to avoid confusion, because normally when I do this, people are confused between the actual person and the object. So we have P1 object, which was created using the object initializer. So the P1 has a first name, then it has a last name, then it has an age, then as stated there, then we have the, so these are the actual things. So this is our object, the P1 object. Hence when we call print details, it's going to execute print details on P1. So that one is not confusing, it's what we are used to. Then let's look at the inheritance part. So that was the base class. The inheritance part, let's start with the student. Student S1 is equals to new student. Again, we are going to use the shortcut approach. Let's see if it's going to work here. So we have the default constructor, then it's inheriting from person. So why are we getting errors? Let's try to do this. I don't think this will work. Nah, this is not working. I don't want to use the long approach. New student. So apparently we cannot access the things. So for this one, let me see. What attributes do we have under student? Or maybe it's confused since we have two student classes. So to differentiate, let's rename this and say student 2. I'm going to rename it because we have clashes here. So I'm going to say yes, because now it's confused. Which student are you talking about? So this class now it's student 2 because we renamed it. So let's do that. So I'm going to go there. It was confused because we already have student there, so that's why it was not working. So here I'm going to say student 2, then S1 is equals to new student 2. Now we can successfully do that. then last name is equals to, then age is equals to whatever age you want. Then also remember, this is a student, so we have to state the student number. Then we have to specify the course. So you see now we can create this object. Notice that it has first name, last name, age, student number, course. Even though we didn't define these things on the actual student class, because of inheritance that was possible. So now we can call that method the print details. So if I go to student to program, I can, after creating the object, I can execute so I can execute s1.print details. So this is going to apply that specific method, the print details method, on this. So when I execute, so where did I have issues? Let me go up and check. Or maybe there's a missing semicolon. Yes. So when I execute this, you will see that for student you are going to have the details, even for person, because yeah, so I think I just made mistakes there and there, but it's fine. So it's console.writeLine here. Then also we like this to start on a new line, so we are going to do this. Same with the student. I'm just fixing, other than that it works the same. Here I'm just fixing the output so that it's cleaner compared to what I have. So yeah, I have something like this. You will see that the person is there, then the student is also there. So the thing that you have to note is that in terms of our S1 object, we are going to have all those inherited things: first name, last name, then age. They are inherited from this class. This is an object, so this is on its own. It doesn't affect this other object. So then additionally, from the student class, we said we have a student number and course ID, or the course. So student number and the course. Then based on what we populated the thing with here on that line of code, where was it? On this line of code, it's going to populate there. So we are going to have John 2, then 13, then 1, 2, 3, 4, what, then the course that they are doing. So this is our S2 object. Then we can do the same process with the lecturer. So we are going to have lecturer, then L1 is equals to new, then lecturer, then it's the same thing. First name is equals to whatever name that we want, then the last name is going to be whatever last name you want, then the age, it's going to be whatever age we want, then the employee ID, remember these ones, they have an employee ID, is equals to whatever we want, then the department, it's going to be whatever we want. Maybe they specialize in informatics, then that's the lecture. And also let me check what is the issue. Lecturer. So we have an issue here, so it's new. So let me see. Oh, it's because of we didn't change, but we did. The constructor is not public, hence we have that issue. So it should work. So we are going to say L1 dot print details. Then this is going to work fine. Or this is going to work as expected. Let's run again. Or maybe we have an existing one. So you will see that with the lecturer we have the information. So that's inheritance. It works like that. Let me check. This is long, but it's fine. Last thing. This is the last thing, I promise. The last thing that we have to do is the overloaded constructor. We saw that with the default constructor it's easy. Now let's look at the overloaded constructor. So overloaded constructor for the derived classes. So the syntax for the overloaded constructor is public, then you have the derived class, then parameters, then you have to call the base class, then you pass like the constructor of the base class, then whatever code goes here. So let's do that in example. In theory it's a little bit, it's not clear, but let's do that. So let's say for the student, for example. So to create for student we are going to say, so never mind this. So for student we are going to say public student to the name of, like the way we do it. So because this is an overloaded constructor, we also have to populate like these person details, first name, last name and age. So we have to receive them. So I'm going to do that. String first name, or let me just say F name, L or let me just do the normal way. First name, last, but this is going to be long. Let me just say first name, string, last name, then int age. So we have int age. So these are for the person class. Then now we have to include these ones. So the way string student number, then string course. So next thing you have to say dot base, then you have to pass the parameters. This is used to call the base constructor. So we want to call from the person, we want to call this constructor. It receives the name, last name and age. So we are going to pass those ones, F name, L name and age. So we are passing these parameters to the base constructor so that it can initialize them. Then as what we are interested in is this, because we have that. So as we only deal with those ones. So we only populate student number is equals to student number, and also course is equals to that. So notice that these ones on our constructor, we dealt with these two. Then the others, these others, because they belong to the base class, we have to call the base constructor, so it deals with those ones. So I think you can do the same with lecturer for practice, but that's how you do a base construct. If you don't understand, you are free to research how it works. So yeah, but I think for this video we'll end here.